Alright, in this video I'm going to go through the trig identities. These are the ones I've been told by a number of people that you need to know well in order to be successful in calculus. So let's go ahead and look at these and let's talk about some things that might help as far as remembering or learning and remembering them. Of course, I actually already did a video on the trig ratios, and so I won't say much about that, and obviously these aren't trig identities, but this is certainly a core part of what we do in trig, and you need to take that with you. Notice this was the original definition that we were given for each of the 6 trig ratios. You can also see the relationship to the right triangle. We've looked at that relationship. And the only thing that's not mentioned here is the unit circle, but we know if r is 1, for example, here, sine of theta would be y. Cosine of theta would be x. And so, and that's what we talked about with the unit circle, and you should be very comfortable with that. All right, so I won't talk any more about the trig ratios. Let's move on to the reciprocal identities. So, by now, with all that we've done, you should know that cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. We could also say that sine is 1 over cosecant. And in some cases you may have to use a relationship like that as you're working with identities in chapter 5. Similarly, this would be, you could say cosine of theta equals 1 over secant of theta, or here we could say tangent is equal to 1 over cotangent. Here's our quotient identities. Hopefully you know those well by now. The Pythagorean identities, those are like really super important. You run into those a lot. And the nice thing about it is you really just need to know this one if you happen to forget these others. Now I remember, these pretty much look the same. You got 1 added to something here. In this case, you have tan squared and secant squared, and here you have cotangent squared and cosecant squared. This is about the only time I can think of where your C's match up in something that you're doing with trig ratios. But how do I get these if I have this? Well, basically, I can divide both sides here by sine squared, and each term ends up getting divided by sine squared. And notice that's 1 plus cotangent squared equals cosecant squared. And so that gives you this one here. You can get this one by dividing everything by cosine squared. So even if you don't remember these, you can find them quite quickly. Now these can be useful. I honestly don't use them very often because with the unit circle I always know what my signs are. But these can be used. If they're useful to you, use them. And there are a few problems where they kind of require you to learn these. But basically, sine and tangent are odd functions, and cosine is an even function. And so that's why we have what we have here. The cofunction identities, remember we talked about how sine of 30 degrees is equal to the cosine of 60 degrees. So basically, if these are complementary, then whatever this measure is, it's going to equal the measure here. And we can do that for secant and cosecant, or we can do that with tangent and cotangent. So for example, tangent of 30 degrees is equal to cotangent of 60 degrees. All right. Sum and difference identities. We didn't write this out in this book, or we didn't write our identities out this way, but basically this means sine of a plus b is equal to sine of a times the cosine of b plus cosine of a times the sine of b. So with the sine identities here, if you have a plus b here, you're going to have a plus here. If it's a minus b, then you would have a minus here. That's all that this is saying. Otherwise, everything's the same. And the thing with sine is you have sine, cos, sine. With cosine, notice that your signs are the opposite. So for example, the cosine of a plus b equals cos a cos b, opposite sign, sine a sine b. So we did a lot of problems in those sections with these identities, so hopefully you're getting them down, but that's how they work. And if this were cos of a minus b, then this would be a plus. Otherwise, they're the same. And then finally, we'll talk about these two here. Now, basically, you can get this one by just using the identity up above and using a plus a, and you end up with 2 sine a cosine a. And we use this one a lot, and then we use these a lot. And it kind of depends on the situation which variation you use. But again, if you know this one here, you can replace cosine squared with 1 minus sine squared a. And basically all I'm using is the Pythagorean identity, either solve for sine squared or cosine squared. And then sine squared, if you replace that with 1 minus cosine squared a, that actually gives you this one here. If you replace cos squared a with this here, you end up with this one here. So I don't know if that's going to help you out as far as learning the identities, but hopefully you're starting to see some relationships here. And in some cases, you can develop the other identities if you forget one using the ones that you know, just like what I was just talking about here and what we talked about up here. All right, so that's all I have to say about learning the trig identities. These are the ones you need to get to know well, and these are the ones that they're going to assume you know when you move on to calculus and you're doing trig types of things.